Have you seen NASA's new image of 3I Atlas yet? Because if you have, I need to ask you something. Does it look the same as the raw images amateur astronomers have been posting for weeks? Here's what I mean. When backyard observers guys just like you and me with telescopes in their driveways captured this interstellar visitor, they saw something that kept changing. Shifting. Moving in ways that didn't quite make sense. Then NASA released their official version, and the moment they came out, I knew something was off. And suddenly, everything looked calm, stable, almost too perfect. So here's the real question. Are we looking at the same object, or are we looking at two completely different stories? By the end of this video, you're going to see exactly what I'm talking about. And you're going to understand why the gap between these two versions matters more than you think. Subscribe and let's begin. Before NASA ever released anything, the first real look we had at 3I Atlas came from regular folks pointing their own equipment at the sky. And that matters here. These weren't images run through some government lab or processed by a team of specialists. These were straight captures, stacked just enough to see the object clearly, then posted online exactly as they came out. 3I Atlas wasn't acting like your typical comet in those shots. The coma, that fuzzy cloud around the center, it kept shifting from one night to the next, like it was moving in different directions. Some nights it looked brighter. Other nights it dimmed and stretched out. A few observers even caught what looked like bends or twists where you'd expect something smoother. And those jets or whatever they were, they didn't always point the same direction. Sometimes the whole thing looked off-center, like it was trying to settle into a pattern but couldn't quite get there. Now that doesn't necessarily mean anything dramatic. It just means the raw images had character. They felt real in that messy way things do when you're looking at them through a telescope on a cold night. No filters, no corrections, just what's actually up there. And because these images kept coming in night after night, people got used to seeing 3I Atlas that way. Rough, unpredictable, alive. That raw version became what we thought this thing actually looked like. So when NASA finally dropped their cleaned up photo, the difference hit you right away. It felt like looking at two completely different objects. And that's when people started asking questions. Once NASA released their official 3I Atlas image, the first thing you notice isn't what's in the picture. It's how calm everything looks. Steady, centered, perfectly balanced. And look, that's not necessarily a bad thing. That's what NASA does. They take the chaotic reality of what's out there and turn it into something clean enough that anyone can understand it without getting confused. But here's the catch. Every step of that cleaning process pulls the image further away from what the amateur astronomers were seeing. When a guy sets up his telescope in his backyard and photographs something like 3I Atlas, he's getting whatever's actually up there. Maybe a little stacking, some basic adjustments. But that's about it. NASA, they run it through a whole assembly line of processing. They strip out the noise, line up the frame with surgical precision, fix distortions, correct dead pixels, balance the exposure across multiple shots, and smooth out all that grain that gives raw images that gritty, real-world texture. They also mess with the color balance, which means what you're seeing isn't necessarily what came straight from the telescope. They adjust the contrast to highlight certain details and hide others. They compress the file so it loads fast on websites, which smooths out even more of those tiny variations. And they sharpen the center to make the core look more defined than it probably appears in real time. None of this is shady. It's standard operating procedure. This is how institutional space imaging works. But every single one of those choices changes what story the final image tells. And that's where things start to diverge. The raw images showed a coma that changed night after night, drifting left one night, right the next, like the object couldn't quite settle down. They showed brightness that pulsed differently depending on the angle. They showed jets that didn't always go in the same direction, sometimes bending, sometimes thinning out in ways you wouldn't expect. NASA's image takes all of that and smooths it into one representative snapshot. A version that looks stable even if the actual object wasn't behaving that way from moment to moment. It's like taking a shaky video and freezing it into one perfect still frame. Technically accurate maybe, but it feels different. The amateur images showed movement, unpredictability, personality. NASA's image shows order, structure, control. So when that official photo finally came out, it didn't match the rough, shifting thing we'd been watching for weeks. One version looked alive, the other looked like it had been through post-production. And that's exactly why people started comparing them side by side. Because the difference isn't subtle, it's the kind of thing you can feel in your gut before you can even put it into words. Now that both versions are out there, the raw frames from backyard astronomers and the polished one from NASA, the most interesting part isn't the images themselves. It's what happens when you put them next to each other, because they really do look like two different versions of the same visitor. In the amateur shots, 3I Atlas looked restless. The coma shifted around. The brightness flickered in ways that didn't match what you'd expect from a normal comet. And the whole thing had that rough, uneven quality you get when something's genuinely hard to pin down. Those details made it feel real, like it was actually moving even when you froze it in a single frame. Then you look at NASA's version. Everything's locked down, the coma is smooth, the contrast is even. The brightness looks steady, like the object held still just long enough for the perfect shot. It's not that NASA did anything dishonest, it's that their job is to remove anything that looks uncertain. And uncertainty is exactly what made the amateur images interesting. So when you put the two versions side by side, you can't help but start comparing. People look at the shape of the coma, the length of the tail, how bright the core is, whether the jets are consistent. They notice how the raw images seem to shift and change, while NASA's looks like one frozen moment that doesn't carry that same sense of movement. And that comparison is something NASA's never been too excited about. Not because they're hiding anything, but because raw and processed images tell different stories, and the gap between them always raises questions. NASA wants the clean story, the one that looks stable enough to put in a press release. The amateurs show the messy version, the one that reflects how this thing actually behaves night to night, moment to moment. That difference becomes even more obvious with something like 3I Atlas, a visitor, that's been challenging expectations from the start. And once people have seen both versions, it's hard not to wonder what each one is leaving out. This isn't about accusing NASA of some grand conspiracy. It's about recognizing that comparing these images isn't just interesting, it's necessary, because somewhere between the raw frame and the polished one, there's a whole story that only shows up when you look at both. Over the next few weeks, we're going to get more data. Hubble and James Webb are both watching 3I Atlas. Ground-based telescopes are measuring the composition, speed, and how much material those jets are throwing off. By mid-December, when 3I Atlas makes its closest pass to Earth, we should have enough information to answer some of these questions. Are those jets just ice evaporating or something else? Are there smaller pieces breaking off, chunks of ice from a natural breakup, or something more deliberate? Is that X pattern in the coma just a trick of the viewing angle or evidence of something we haven't seen before? But here's what we know right now, today, without waiting for more telescopes or more analysis. The same object can tell two completely different stories depending on how much processing it goes through. And when those stories don't quite match up, when the polished version looks too stable compared to what the raw captures are showing, that gap is worth paying attention to. Not because it proves anything dramatic, but because it reminds us that every image we see has been shaped by human hands. Every choice about what to enhance and what to smooth away is a choice about what story gets told. When you look at the raw images of 3I Atlas and then look at NASA's version, it almost feels like you're looking at two different moods of the same object. One is rough, uneven, shifting in ways that feel honest. The other is calm, balanced, the kind of image that looks like it was designed to be trusted. And maybe both are true in their own way. Space is messy and science is careful. That's just how it works. But that gap between those two pictures, that space where things don't quite line up, that's where the real story is. If this got you thinking, if you felt that pull to dig a little deeper, drop a comment below. Tell me what you think. Tell me what you're seeing. If you want to keep exploring these mysteries with us, hit that subscribe button. Because we're just getting started. The universe is full of things we don't understand yet. Some of them are hidden out in the darkness between stars, and some of them are hiding in plain sight, right there in the gap between two versions of the same image.